So I want to find the average value of this function f of x, y, z over the points inside the hemisphere radius 4, centered at the origin with its base in the xy plane. So let's draw just a real quick picture to get a rough idea what it is that we're actually talking about here. So if this is the xy plane, I have this hemisphere of radius 4, which means it'll come out to 4, come out to 4, likewise out here to 4. So picture this as being a circle on the xy plane. And if it has a radius of 4, then it's going to hit the z-axis up here at 4. So it's going to come up like this. And of course down here like this. You can kind of picture that as being, well, I kind of messed that up. But anyway, yeah, pretend like that's a half a hemisphere, okay? All this is above. So I know that this piece right here, I can write this as y is equal to the square root of 16 minus x squared. That's what gives me the top. And obviously the bottom would be the negative of that, so I can think of y as being plus and minus that. Now this top piece here, the actual sphere itself up here, I can think of that as being z is equal to square root of what I have here, 16 minus x squared minus y squared. That will give me this upper sphere. So I know that z will go from 0 to this function. And y will go this way, so to go from the negative of this to the positive of this. So let's go ahead and write that thing out. Oh, and then obviously x is going to go from negative 4, which is over here, to a positive 4, which I kind of covered up. So let's go ahead and just, like I said, write this triple integral out real quick. It's going to be of 6 x, y, z. And if I think in terms of dz first, z is going to go from 0 to the square root of 16 minus x squared minus y squared. And then, see, that covers z. Y, if I do y next, y is going to be from, it's going to be hard to fit it in here, but it's going to be from a negative square root of 16 minus x squared to a positive square root of 16 minus x squared. That covers these two. And then last but not least, I want my x. I definitely want my x last because that has the numerical values that will help ensure that I actually get a number out of this thing. Now, it wants the average value of this. So remember, the average value could be this divided or multiplied by 1 over the volume of the region. Well, the volume of a sphere is 4/3 pi r cubed. But I have half of sphere, so I need to multiply this by 1/2, which means that's 2/3 pi r cubed. And r in this case is 16, so I'm going to have 2/3, I'm sorry, r is 4, 2/3 pi times 4 cubed. So this integral will be 1 divided by 2/3 pi times 4 cubed, which is 64. So I guess I could just write this as 128 pi. Don't forget that 3. So it's going to be 128 pi over 3. So it's going to be 3 over 128 pi times the triple integral of all of this. So I'm just going to do all that stuff again. So it's dz, dy, dx. So now we're set up and ready to rock and roll with this thing. So let's go ahead and actually look at the integral. So I'm going to take this first piece here because as respect to z, there's no z's in here, so I'm not going to look for any cute substitution. I'm just going to go for it. So with respect to z, this is going to be, and I'm just calling this constant k. So let's just let k equal this thing and just stuff it aside someplace. Set k aside somewhere so I don't have to mess with it all the time. And actually, I'm going to get rid of that 6 too. 6 times 3 is 18, so I'm going to just make this 18. Worry about reducing that later. Who cares right now? And I'm just going to not deal with that 6 anymore. So I'm going to have k times, I'm integrating with respect to z, so I can pull out the xy. I have the integral from 0 to the square root of 16 minus x squared minus y squared, z to z, which is going to be that constant k times xy times, I guess I have a 2 here to worry about because it's z squared over 2. So it's just going to be 16 minus x squared minus y squared. Okay, so that's what I now need to integrate. So now I have k over 2 times, what's the next integral with respect to y? So I'm just going to leave this x out here, times the integral from, negative square root of 16 minus x squared to the positive square root of 16 minus x squared of, when I multiply this y through, I'm going to have 16y minus x squared. Yeah, you know what? I'm not so sure I want to do that. Yeah, maybe I will. Okay, so I have x squared y minus y cubed dy. Now, when I integrate this with respect to y, I am going to get 16y squared over 2, which I'm going to leave that constant. Just leave this alone for a little while. I'm going to have 16y squared over 2, which is 8y squared minus x squared y squared over 2 minus y to the 4th over 4. Evaluate from a negative square root of 16 minus x squared to square root of 16 minus x squared. Which, actually, I can stop now because I'm really done. I don't know if you noticed or not, but this is an even function. So I have an even function evaluated from the square root of 16 minus s squared to the negative of 16 minus x squared. I'm going to be subtracting that. That means these could be the exact same values. That means when I do this, I'm going to get 0. So the next integral is just simply going to be the integral of 0, what was last? dx, which is just 0.